Question number 21, worksheet connected particles. Two particles P and Q have mass m and 1 minus m kgs respectively. The particles are attached to ends of light inextensible string which passes over a smooth fixed pulley. P is held at rest with string taut and both straight parts of the string vertical. P and Q are each at height 8 meters above the ground. P is released and Q moves downwards. Okay, so Q moves downwards. That means P moves upwards. Okay. Subsequently, Q hits the ground and comes to rest. Figure 2 shows velocity time graph for P while Q is moving downwards or Q is at rest. Find the value of H. Okay, so let's look at the velocity time graph given for P. So initially we can see that the speed is 0. And then as P goes up, since Q is going down, its speed increases with a certain acceleration and it becomes 2 eventually. So here V is 2 and U is 0. Okay. Same will happen for Q. Here U is 0 and V is 2 since they're connected particles. We can also find the acceleration from here. Acceleration is rise over run from speed time graph. So acceleration is 2 upon 0.5, which is 4 meters per second square. So we know the acceleration of this part of the journey 4. Same for this one 4. Okay. Now since we need this distance covered, which is the height, I need to find the value of S from these values. So I can use S is equals to half U plus V times T. 0 plus 2 times 0.5. Okay, this is just 0.5. So the height or the distance above the ground is 0.5 meters. Okay. Next is find the value of M and find the tension in the string while Q is moving. Okay, so looking at P, there's an upward force of tension and then there's a downward force of weight, which is going to be 10 M since its mass is 10. So at P, the equation is going to be forward force minus backward force is equals to MA and A is 4. Now at Q, since it's moving downwards, the forward force is going to be its weight, which is going to be 10 times 1 minus M, and the backward force is going to be tension. So 10 times 1 minus M minus T is equals to mass, which is 1 minus M times 4. This is going to be the second equation. You're going to solve these two equations simultaneously on your own and get M is equals to 0.3 and T is equals to 4.2. This would be in kgs. This would be in newtons. Okay. Part 3. String is slack while Q is on rest on the ground. Okay. So since Q hits the ground, now the string slacks. That means there's no tension in the string. And this P does not stop here. It goes a little up because of the string slacking. And here its final speed becomes 0. And this will be the U now. Okay. And we know that in slacked state, the acceleration of the particle is equals to the gravitational acceleration, which upwards is minus 10. And since this particle is going upwards, so in the slacked state, which like goes from here to here, the acceleration is minus 10. So we know that U is 2, V is 0, and A is minus 10. What do we need? Find the total time from the instant that T is released until the string becomes taut again. So first, to go from here to here, it takes 0.5 seconds. Then to go from here to here, we have to find that time t. And then it comes down as well. So we double that time. So we're going to add zero point 0.5, then the double of the time we're about to find. Okay, how do we find this? We can use v is equals to u plus at. So 0 is equals to 2 minus 10 times t. T comes out to be 0.2. So the total distance P covers is, sorry, total time P takes is 0.4, sorry, 0.5 and going from here to here. Then it becomes slack 0.2 seconds, stays slack for 0.2 seconds. Then in another 0.2 seconds, it falls down and becomes taut again. So this would be 0.9 seconds.